Howdy and welcome to Solving Problems Part 2. Now, last time we looked at some finance stuff, but it had to do with regular investments. You know, we went every month and we put some money in and it was growing. Today we're going to look at what if you were trying to pay off a loan. And I've got an example right here. So you borrow $170,000 at 3% compounded monthly. You make monthly payments of $2,000. How long to pay this thing off? And again, mathematicians have developed a formula, which you don't have to memorize, it will be provided, but a formula for this kind of a loan problem. So it looks like this. The present value, now I'll explain, present value is the amount that you presently owe. So this is really just the amount owing is what present value is. And here's what we can plug in. The regular amount that you pay, so your regular payments, times 1 minus, and then in brackets 1 plus the interest rate, which might be tweaked, especially if it's like in this example, it's 3% compounded monthly, so we'll have to tweak that I, and then negative n is the exponent, and n is the number of times that this, it's not a growth, but that this reduction occurs. Okay, and that's all over the interest rate again, which has to be tweaked. Okay, so what you got to do is build all the bits and pieces from the question into the formula, and once it's in the formula, you may have to use logarithms or some fancy math to actually solve it. So I'm going to clear the screen here and then start putting the information in. Okay, so present value, what we owe is $170,000. That's our starting amount there. And over here, the regular contributions that we're making is $2,000. We're doing it every month. Then we have in the brackets 1 minus, and then we have in brackets here 1 plus the interest rate. Now, I haven't left much room for myself, so I might have to put it on the side. It's 3%, so 0.03, but I got to divide that by 12 because that happens every month, compounded monthly, and that's raised to the negative n. Okay, and that's the stuff on the top. And then on the bottom, I got my tweaked interest rate, so my 3%, 0.03 divided by 12. So this is the mess that I'm going to have to try to solve. So I think where I'm going to begin on this is we could take this denominator here, and basically we're going to multiply this number on both sides. So whatever that is, I'm basically multiplying both sides by 0.03 divided by 12. So that's what I'm doing over here. 0.03 divided by 12, whatever that is. But over here, that's going to be nice because then I don't have a fraction. See, I can just cancel that out. Now, I did this ahead of time on the calculator, and I got 425. And what can I do to simplify things over here? Well, I got that 2,000 sitting there. Not much I can do about that right now. And then what I did was I combined the 1 plus the 0.03 divided by 12. I just put those two numbers together, and that gave me 1.0025. And of course, that's raised to the negative n. All right, so at least I don't have any fractions anymore. So next thing I did was I divided by the 2,000. So I went 425 divided by 2,000, and I got this decimal number. All right, and here's what it leaves me on this side. So I've got all the stuff in the brackets. Okay, you can see what I'm trying to do. I want to isolate the stuff that has the exponent of the negative n here. So next thing I'm going to do is I'm going to take 1 and subtract it from both sides. So I end up with negative 0.7875, and that equals negative 1.0025 to the negative n. Now the next thing I thought would be smart is, if they're both negative numbers, why don't I just multiply both sides by negative 1, and so I can make that a plus and that a plus. It just, it's less hassle, less junk floating around that's going to cause me trouble. Now my unknown is the exponent here, so I have to take logs of both sides. That's what's going to bring that guy to the ground. So on this side, I have log of 0.7875, and I can now bring my exponent out in front of the logarithm, so it's negative n times log of 1.0025. All right, looking very hopeful. Next thing I'm going to do is I'm going to divide by this log of 1. Just sneak it over here. Divide by the log of 1.0025, which gets rid of this. And the only thing is that this answer is going to look silly because it equals negative n. So I'm going to multiply both sides by a negative. So that gets rid of the negative n. So now I've solved for n, and it's whatever this turns out to be. Well, I did that on my calculator, and I got 95.68. So that's what n equals. Now remember, n is the number of, basically number of payments. It's the number of times that this compounding decreasing has occurred, or in this case, loss periods is a way to think of it. So how can I convert that to something more tangible? You could say this is the number of months because I'm making these payments and these transactions are occurring each month. But if you want, you could do this and say, well, why don't I take the number of months and divide by 12, and then it becomes the number of years. So that's probably a little bit more reasonable for most people. They like to see something like this. All right, so just under 8 years, and you will have paid off your loan. So that's a very nice answer and very reasonable. So that's where I'm going to stop. We're going to come back with one other example of something not to do with finance in a little bit.